Alright, hello everyone. Um, Here's the long form video explaining how that stuff works. It's bare minimum, essentially. Right here is my authority stuff, which is basically how it detects whose it should be really smooth on. And keep in mind, it's still fairly smooth for everyone, but it just runs best whenever it's on its authority. So we get the local player, and we compare it. Is it the authority of the object, which is down there, and is it the player inside of the seat? And we check if that's true for both, and if it is true, and if both are true, which is what we use this AND for, it comes out. Now, this right here allows us to set the authority of the object to the person who's just gone inside of the seat. This is very useful for making it seamless and just allowing people to just hop in and get going. Now, here is our throttle logic. A lot of variables in here. I'd prefer it if there weren't, but it's just to help me essentially. So, I don't mind the depreciated stuff. That's fine for right now. We get the rotation, and that's inputted into a quaternion. Quaternions are a whole nother can of worms that I'm not going to get into. And help, just show differences and stuff. There we go. And there we go. So the very first thing here is we rotate the vector by the inverse of this rotation. We take that, we store it into this variable, and next we get the inverse of this position. The first one right here, this is for a player who's inside of it, and this is the throttle trigger handle, which is the red one. We then put that this one into this variable, and then we subtract the two. We get the magnitude, which is essentially how big the vector is, right? It should be normal. It shouldn't be very big. And then we're able to put it through here, the min, the max. This is just our constriction. And this is the way that we basically get it. If it's above a certain threshold, you start accelerating. If it's below this threshold, you start decelerating. And right here, it's just checking if the player is valid. And if the player is valid, it'll allow it to run. If it's not, it cuts off. But this is kind of redundant, considering this right here already checks if there's someone in the seat. It's just, I don't know, it's a good habit for me. This is my throttle, my speed logic. This is custom made. It's very useful. You store the speed in a variable. This is our base variable. We will then add it together with the acceleration, or subtract it with the deceleration, depending on if this is actually supposed to be if it's above this threshold, but I forgot to rename that, so my bad. And it also detects if the trigger handle's primary trigger is held, and if it is held, it'll run through here. It'll run down and start doing all this math stuff. So basically, if it is above the threshold, we use the addition. If it's not, we use the subtraction. These two right here check if it's above zero, or if it's below zero, or above the maximum speed. If it is above the maximum speed, we then do that. We put it to 60, which is our maximum. If it is not, we put it through here, and vice versa for here. If it is less than zero, we put it at zero, and if it's not, we keep decelerating. We then put that through here, and this sets the speed. Now this right here is something that you don't need to make a working one at all. I just think it's nice for very sharp turns. It shows you the direction relative to this, where you're going. So let's say you're doing a very sharp turn upwards. It'll tell you that you are now going up. And it'll keep going that due to it, even if you're going directly down now. But to change that, you'll have to do down, and so on and so forth. You get the rotation. You do the inverse of the rotation. Rotate that one by the object's forward vector. I think, wait. Yes, I'm sorry. Yeah. You normalize it, then you do a whole bunch of vector dot math, which I really don't want to get into. Put that into a list, find which one is the biggest, and from that one we get the index of it. And 0, that's right, left, up, down, and then forward. Normally it should be forward, which, because right now nothing's going on there, it really doesn't matter. And finally, here, really quickly, I will show you what this stuff goes into. For your turning logic, that's it. Your turning logic goes into angular velocity set. The target is the Rec Room object at first with tag, and I tagged it with 1. The next ones all the way down there is 1 through 7, and so on. And for velocity set, it uses the forward vector right here, which is also hooked into the Rec Room object at first with tag. And after that, this is also completely redundant. I don't know. Right here is a very simple HUD system which we use to display stuff like the direction, the speed, and its altitude. We have to do some subtraction because it's not perfectly to the floor, because I did some testing with this to get me a good pivot point. Yes, I do model this shit out. And we put this into a string format. String format works in a way right here. So whichever one's the first one, you put a 0 in these little brackets. The second one, you put a bracket, 1 bracket, and so on and so forth. Very simple once you get down. What the fuck? Okay. Anyways, yeah. Very simple once you get down to it. That is the basic system that I use. It seems super complicated, and at first it can be. But don't let that dissuade you from making something cool. If y'all do want this system and you don't want to make it, I will be publishing it, and I'll be publishing different vehicles that I've made and I'm working on. It's just fully functioning, ready to go out the box sort of stuff, okay? And if you would rather just pay a little extra tokens to get that, I'd say go for it. It'd support me and allow me to make more stuff. But other than that, that is the basics of the system. So this is literally just to detect if the throttle is being held down for this part. This is to detect if the turning thing is being equipped, so that way, if it's not, you can just skip setting the angular velocity and just go right into the velocity set. And that's the gist of the system. It's very, very efficient. Well, not really. It's good for what it is. Shall I phrase it like that? It's good for what it is. For me, just doing this shit for fun. Yeah, that's basically all there is to it. It's super simple for me, and I hope this helped out with understanding how this works.